Here we are looking at molecules, all containing 4 atoms, but the molecular geometries are very different, and the reason for that is because their electronic geometries are different, and that is because the number of charged clouds are different. On the left hand side we have a charged cloud of 3, in the middle we have a charged cloud of 4, on the right hand side we have a charged cloud of 5. On the left hand side we have formaldehyde, also called methanol, and we have the grey carbon, the white hydrogen, and the red oxygen. So there are 3 charged clouds. When we count the charged clouds, we count the double bond as 1 charged cloud, so we have 3 sets of bonds, so we have 3 charged clouds, and the electronic geometry is trigonal planar, and the molecular geometry is trigonal planar because we don't have any lone pairs present. In the middle we have ammonia, and you can see there are 4 charged clouds. We have 3 charged clouds coming from the bonds between the nitrogen and the hydrogen, and we have a charged cloud coming from the lone pair. So in total we have 4 charged clouds, so the electronic structure or geometry is tetrahedral, and the molecular geometry is trigonal pyramidal. So even though we can't see the lone pair when we look at the molecular geometry, that lone pair influences your molecular geometry. So the method is always to first find the number of charged clouds, get your electronic geometry, and from that deduce your molecular geometry. On the far right we have a chlorine in the middle with 3 fluorines on the outside and also 2 charged clouds. If we count our charged clouds, we have 3 coming from our bonds between the chlorine and fluorine, and we have 2 charged clouds coming from the lone pairs, so in total we have 5 charged clouds. Because we have 5 charged clouds, we are placing those lone pairs on the equatorial position. You have to place the lone pairs in the correct position to be able to get the correct molecular geometry. So if you have 5 charged clouds, those lone pairs must be on the equatorial position. If you have 6 charged clouds, those lone pairs need to be on the actual position. So now we are dealing with a charged cloud of 5, so we have placed those lone pairs on the equatorial position. Our electronic structure deduced from the 5 charged clouds is trigonal bipyramidal, but our molecular geometry is T-shaped because we cannot see those lone pairs, but those lone pairs do influence the molecular geometry. Without those lone pairs we would have had trigonal planar, but now we have those 2 lone pairs present on your chlorine atom, the green one in the middle, and therefore our molecular geometry is not trigonal planar but T-shaped. So always you have to take into account the electronic geometry, from that you deduce your molecular geometry because of those lone pairs influencing the shape of your molecular geometry.